Be the conclusion to lesson 1 of the pre-calc summer supplement. We want to go back and take a look at the examples that we've already looked at. I told you that this is the answer, but we need to add just a little bit to that answer. This answer is almost a complete answer. We need to make sure that we are considering that we're dealing with fractions. And when we are dealing with fractions, we always have to keep in mind the denominators. If you remember way back when I first showed you the that property where you can multiply the numerators and multiply the denominators, and that makes it okay to cancel, we need to keep in mind that denominators are not allowed to equal 0. So what you really need to do when you finish each problem is go back and say what A, B, C, what the variables are not allowed to be. So for example, if I'm looking at this particular rational expression, B is in the denominator. As a matter of fact, the part that contains B is B squared. So B squared cannot equal 0. And when you're thinking about not equals to, consider it an equal when you're simplifying it. That means that B is not allowed to equal 0. Here, C, it's a denominator, so C is not allowed to equal 0. That would give you an undefined answer, so it's not allowed. A, once again, since A cubed can't be 0, that means that A is not allowed to equal 0. So this answer is almost complete. The only thing that we need to add to that is to say 3c over 20ab for A not equal to 0, B not equal to 0, and C not equal to 0. Now this may not seem like such a big deal to you, but when you get into graphing, when you get into other things, there are exceptions. There are numbers that are not allowed to be equal to the variable. Sometimes it'll be zeros. These are zeros because they're standalones, and when you multiply anything times 0, you get a 0 in the denominator, and that's a problem. But what we're going to do is we're going to go back through all of the examples, all but the ones that are plain numbers, and find out what are the exclusions, what are the things that the variables are not allowed to be. So let's go back to example 2. Example 2, we found that was our answer. But now we want to find out, wait a minute, what's the real deal? What do we need to add as a qualifier for that answer? In other words, what's not allowed to be what? So we look at the original problem, and you see that x can't be 0, because that would give you a 0 in the denominator. C can't be 0, because that would give you a 0 in the denominator. And y can't be 0 either, for the exact same reason. If you had a 0 down here and multiplied it, you have a 0 in the denominator, and that just can't be. So this is our answer as long as x is not 0, works for all the other values of x, c is not 0, and y is not 0. So I held off on this little detail because the other things are much harder to get, but this detail is important, and we want to make sure that we've got it. Alright, so example 2, this is your real complete answer. Okay, let's go back and hit 3. Once again, I'm going to get rid of these extra words. We're going to take a good look at this example. And we find that that is almost our answer, except we need to look for our exceptions. I'll fix that up a little. There we go. Let's look back at the originals. Now this is an interesting thing because with a division problem, you end up having extra denominators that you need to check in the next step. So let's start off by looking at this one. This one tells us that A can't be 0. This one tells us that B can't be 0. But we've got a dividing sign here. That means that this whole thing actually counts as a denominator. This counts as something that you can't have being equal to 0. So if this thing is equal to 0, the whole thing also blows up. So we need to also look at this denominator. If a variable shows up in any denominator, it means that that piece can't equal 0. So A and B come from here and here, but X also can't equal 0, and Y also can't equal 0. Okay? Because any of those equaling 0 would give you an undefined fraction somewhere along the problem. So our whole answer here is this is our answer for A not equal to 0, B not equal to 0, X not equal to 0, and Y not equal to 0. Okay? Now we need to just be careful, or you're given a complete answer, or at least acknowledging at this point that there are some exceptions. A can be any number except 0. B can be any number or fraction, and this comes out as long as it's not 0. We can't have anything undefined. If you just have a number in the denominator, it's fine. You just have canceled it out, and there are no exceptions. This is just the answer. Now, this one's an interesting one because it's not just A not being equal to 0. So let's get rid of this, because I want a little bit more space here. We have to get our exceptions in here. Now, looking at the original problem, it's not in factored form yet, so you can't really tell what the exceptions are. So when you're trying to determine what can't be equal to 0, you have to look at the factored form. So we want to take this one to determine what can't be 0. Remember, whenever a factor is 0, it means that when it's multiplied times the rest, it will give you a 0. So here we have A can't be 0. That one's easy. That's one we've talked about before. A can't be 0 because this putting a 0 in here will be 0 times something in the denominator. It would wipe it out and give you an undefined. But there's another one, and that's A minus 3. A minus 3 also can't be 0, because if that was a 0, it would turn this into an undefined fraction, and we can't have that. That means that A can't be 3. A can't be 3 because you add 3 to both sides and you find out. So our real exclusion here is that A can't be 0 and A can't be 3. So sometimes there's a couple of things that a particular variable cannot be in the final solved version, simplified version. Okay, so let's move right along. Here's this example. We have our answer, but let's take a look a little bit deeper and find out what can't be equal to something. We can't have any zeros in the denominator. So let's take a look. This is not in its factored form, so it's not particularly useful in telling what can't be in the denominator. But this is, we have three factors in the denominator. None of them are allowed to be 0. So x minus 2 can't be 0. X plus 2 can't be 0. And x plus 1 can't be 0. So we'll simplify them a little bit. This means x can't be 2. X can't be negative 2. And x can't be negative 1. So here's our answer for x can be anything but 2 or negative 2 or negative 1. So it can't be any of these three values, or we get 0 in the denominator, which is undefined. You can't divide by 0 because division is how many times that thing gives you the original thing, and anything times 0 is 0, so there's just no answer for those things. Alright, let's move right along. Here's another one that we carefully solved, and we got the answer. This one's going to have quite a few exceptions. We have a lot of things that showed up in the denominator here, and none of them are allowed to equal 0. W minus 8 can't be 0. So that means W can't equal 8. So we'll put that one in for W not equal to 8. Notice the 8 wouldn't be a problem in the simplified form, but since it was a problem in the original form, it has to be excluded. W minus 10 can't be 0. So that means W can't be 10. W minus 5 can't be 0. So W can't be 5. And W minus 4 can't be 0. Which means W cannot equal 4. So W can be any number in the whole grand scheme of numbers except for 8, 10, 5, and 4. Because all of those will put a 0 in a denominator and mess it up. So you should always go through and evaluate the numbers that these things can't be. So let's take a look at the last couple. Here's one, here's an answer. You need to go back and look at the steps and find out what x is not allowed to be. It's the only variable in there, so there may be some exclusions for x. So we'll take a look at that. Okay, once it's all factored, well, first of all, we have a little bit hidden here because we have to take a look at this one and this one because they're both denominators, but we also have to take a look at this one because it turns into a denominator. So when you factor this, you get this one. So right down here we know that x minus 3 can't be 0, and x plus 1 can't be 0. Okay, so there are our first two exclusions that come right from this one. So x can't be 3, and x can't be negative 1. I put down here 4, x not equal to 3, x not equal to negative 1. Let's get the other details in here. This one, the factored form is right here, but this tells me that x plus 1 also can't be 0. Now we already took care of that one, but we should still check. We should take a look and make sure that we don't miss it. And then finally we have x minus 2 that also can't equal 0, so x can't be 2. Alright, so that's that one. And finally our last one. Got to find our exclusions here. Now this was a big problem. There was a lot to do in this one. And we've got this compound fraction here. We just have to make sure we don't miss anything. First one that we look at, this 2a plus 2. When that one ended up getting factored, that's where this a plus 1 comes in. So a plus 1 can't be 0. So a can't be negative 1. We'll take a look at another one. 4a is also a denominator, so 4a can't be 0. So that means that a can't be 0. And finally, 10a minus 20 is a denominator along the process. So that one factored out is here. So a minus 2 is also not allowed to be 0. That means a can't be 2. Alright, so that was just our last little bit of lesson 1, the part where we show what values that variables are not allowed to have so that we don't end up with any hidden zeros in the denominator. And that's it for that. What you should do is go back to your lesson 1 practice problems, and just go through and make those adjustments and find out what your variables are not allowed to be. And you can check them. The answers to those are all posted as well, right along in the lesson 1 set of problems. Okay, thanks and have a great day.